Okay, so for the square root of a negative, we talked last class that anytime you have a negative under the radical, you take out an I. Okay, so a complex number is where you have a real number and an imaginary number. Okay, so a plus bi is the standard form for a complex number, where a is your real part and your bi, that I is imaginary, so that's your imaginary part. Okay, so anytime you're working something out, you're going to have your real plus your imaginary. That's your standard form. So what we're going to do when we are adding and subtracting, we're going to drop the parentheses and combine like terms. But when you drop the parentheses when you're subtracting, remember that you've got to change the signs of everything that comes after that minus sign. Okay, because really what you're doing is distributing a negative 1. Okay, so if I have 8 minus I, I'm going to drop that, and then I've got minus the entire 5 minus 4i, so that's going to turn into a negative 5 and then a positive 4i. So you're going to have to be careful when you're subtracting. Okay, from then you combine like terms. So I've got 8 minus 5, which gives me 3, and then negative I plus 4i is going to give me 3i. So 3 plus 3i is my answer. Okay, so then if I'm doing plus, all I'm doing is bringing everything down. 3 plus 2i plus 8 minus 9i. Combine my like terms. I've got 3 plus 8, which is
11.
And then 2i minus 9i.
Minus 7i.
Yep, minus 7i. So 11 minus 7i would be your answer. Okay? Now, when we move on to multiplying, we've got to remember what I is. Okay? So the square root of negative 1 is where we get our I. So if we were to take I and square it, that means if I go back to my definition of what I is, I square the square root of negative 1, and that just leaves me with negative 1. Because the square root of any number times the square root of itself is that number. So if I took the square root of negative 1 times the square root of negative 1, I would just be left with negative 1. We're going to have to memorize this, and then we're going to use that concept the entire class. So whenever we look at this next example, we've got negative 3i times 5 minus 2i. So we're going to treat this I like it would be an x. Okay, we're only going to multiply the numbers. So I'm going to distribute negative 3 times 5, and that's going to give me negative 15i. And then I'm going to have negative 3i times negative 2i, and that's going to give me a positive 6. I times I is I squared. Okay, you have to write that I squared part. Okay, then we know I squared is equal to negative 1. So what I'm doing is I'm taking 6 times my negative 1. So this is really negative 15i minus 6. But if I were to box that, would I get full credit? No, because it's not in standard form. I've got to have negative 6 minus 15i in standard form. Okay? You understand that? Okay. So then the next example, I've got to FOIL it. So I'm going to have 9 times negative 4, negative 36. 9 times 7i, 63i. Negative 2i times negative 4 is going to give me a positive 8i. Then negative 2i times 7i is a negative 14i squared. Okay? So I need to combine my like terms and clean up this negative 14i squared. So I'm going to bring down this negative 36. 63i plus 8i is going to give me 71i. Now this right here, I'm doing negative 14 times negative 1. So that's really going to be a positive 14. So what you're doing when you have an I squared is this term just changes signs because you're multiplying it by a negative 1. Okay, so then negative 36 plus 14 is going to give you
Negative 22.
plus 71i. Y'all good with that? Okay. So here I've got 12 plus 5i times 3 plus 4i. So I'm going to practice that again. 12 times 3 is going to give me
36.
12 times 4i,
48.
48i. Then 5i times 3.
15i.
And then 5i times 4i.
20i squared.
Very good. Okay. So then combine my like terms. I've got 36 plus what? 48i plus 15i.
63i.
And then that 20i squared turns into
Negative 20. Negative 20.
just negative 20. Yep. 36 minus 20. Yep. 16 plus 63i would be my final answer. Okay. Now when I do 4 minus 3i and all of that squared, what am I doing there?
You're just like multiplying it by itself.
So squared is anything times itself. So I'm just going to write 4 minus 3i again. And I'm going to FOIL that. So 4 times 4,
16.
4 times negative 3i.
Negative 12i.
And then I do it again. Negative 3i times 4 is another negative 12i. And then negative 3i times negative 3i is a positive 9i squared. Combine like terms. I've got 16 minus,
24i.
and then that 9i squared turns into
Negative 9.
16 minus 9.
That'd be 7.
7 minus 24i is my final answer. Y'all good with that? Do you have any questions so far? Okay. I guess because the I part is like a variable. So okay, so now what happens whenever you've got multiple sets of parentheses that you're going to multiply? Okay, what I would do is just do your first two, get that, and then multiply that by the third. Okay, do it step by step. So I'm going to FOIL 1 minus 2i times 3 plus I. So 1 times 3 is going to give me, in parentheses, 3. And then 1 times I is just going to be I. Then negative 2i times 3 is a negative 6i. Then negative 2i times I is a negative 2i squared. Okay, and that stays in parentheses because I still have that negative 4 minus I in parentheses at the end. Okay, then I need to clean it up. So I've got 3i minus 6i is going to be a negative 5i. Negative 2i squared turns into positive 2. And then minus 4 minus I. Okay, so then 3 plus 2 is, so 5 minus 5i times negative 4 minus I. You follow me so far? Okay, so I'm going to multiply it. 5 times negative 4 is negative 20. 5 times negative I is a negative 5i. Then negative 5i times negative 4 is a,
Positive 20i.
and then negative 5i times negative I is a positive.
5i squared.
Very good. Okay, combine. So I've got negative 20 plus,
15i.
and then that 5i squared turns into,
-5i.
so my final answer should be negative 25 plus 15i. Sound good? Alright. So you know how last class we said you could not have a radical in the denominator? Well, you can't have I in the denominator either because I technically is the square root of negative 1. So we're going to have to rationalize that. So if I've got 5 over 4i, the only part I want to get rid of that's wrong is that I. So that's what I'm going to multiply by. So I rationalize by I. My numerator becomes 5 times I, which is 5i. And then my denominator, 4i times I, is 4i squared.
I'm kind of like trying to catch up.
So you're going to treat the I like we do our radicals. That's the only part that's wrong. We're going to multiply it by itself. That's going to turn into I squared. The reason we can do that is because I squared is negative 1. Okay, so I've got 5i in the numerator. 4 times negative 1, negative 4. Okay, but can I have a negative in the denominator? No, so I just bring it up, and it's going to be a negative 5i over 4. Okay, so if I've got negative 2 minus 5i over 3i, again, the I is the only part that I need to get rid of, so that's what I multiply by. But now my numerator, I've got 2 terms in parentheses. I'm going to have to distribute that I. So it's going to turn into negative 2i minus 5i squared all over 3i squared. Okay, well, that negative 5i squared turns into positive 5, and this 3i squared turns into negative 3. Y'all see that? Because you're doing 3 times negative 1. So this is giving me, if I were to just write it out, negative 2i plus 5 over negative 3. Okay, I've got two things wrong with that. And it's not in standard form. Okay, so I'm going to take care of both of those at the same time. Okay, the 5 needs to come in front of the negative 2i, so really it should be 5 minus 2i, but I need to take care of this negative. Okay, so when I have a negative in the denominator, earlier this was easy because I could just bring it up, but I can't just bring it up and make only the 5 negative, right? Everything is going to change signs because essentially I'm dividing by a negative 1. Okay, y'all remember that from last class? Okay, so this is going to turn into a negative 5 plus 2i over 3. I would check to simplify 5, 2, and 3, but they can't be simplified. So that is my answer. Y'all good with that? Okay. All right, now conjugates. Last class we did it with the radicals, and it took quite a bit because you had a whole lot going on at once. They said earlier that the I's were so much easier. Okay, so the same concept with conjugates is going to happen this time like last time. So remember, if you've got A plus BI, its conjugate is the exact same thing except a different sign in the middle. So A minus BI. Okay, we're going to use that concept to rationalize. Now remember, when you had this, all that happened was you took the first term and multiplied it, and then you had the second term and multiplied it, and you should always have a minus in the middle. All right, y'all remember that? So Same thing, except now you're going to have an I squared we're going to have to clean up. Okay? So if I've got 7 plus 5i over 1 minus 4i, I'm going to multiply that by what? 1 plus 4i. Because its conjugate is the exact same thing, just a different sign in the middle. Okay? I'm going to have to FOIL the numerator. So 7 times 1 is 7. 7 times 4i, 28i. And then 5i times 1 is 5i. Then 5i times 4i is 20i squared. Okay? Now the denominator, it's a conjugate. So I do 1 and 1, which is 1. Negative 4i times 4i is negative 16i squared. Okay, so for those of you who weren't here last class, the conjugate allows us to do a shortcut. We don't have to FOIL it. Okay, the pattern is first times first minus second and second. Okay, so I'm going to clean up my numerator and the denominator. So I've got 7, 28i plus 5i is going to give me 33i. This 20i squared is going to turn into negative 20. And then I've got 1, the negative 16i squared turns into plus 16. Y'all follow me? Alright, 7 minus 20 plus 33i. And then 1 plus 16 is 17. I would check negative 13, 33, and 17. Those cannot be divided by the same number. So that's my final answer. You're good with that? None of these cannot be divided by the same number, so that's just my answer.
So for the denominator, it's just the first on the
Mhm. Yeah, that's why we use conjugates, to be able to do that. Because if I FOILed it, I would have 1 plus 4i minus 4i, and then that minus 16i squared. Those will always cancel because of what a conjugate is. So that's why we just do the shortcut straight to that.
do we always conjugate the denominator?
Yes, because we're trying to get rid of that I, and that's the only way, because it gives me that I squared, which turns into the negative 1.
So the only reason, just want to be sure, the only reason that the 1 minus 4i became 1 plus 4i is because the denominator can't be a negative?
It's because you don't want that I there, and so we use what's called a conjugate, so that whenever I would do the long way of FOILing, this will always cancel out. So by changing that middle sign, those two middle numbers, if I were to FOIL it, would always, always, always cancel. So that's why we use that.
Simply takes time.
Yeah. So 6 minus 3i over 4 plus 3i, I'm going to multiply by its conjugate, which is 4 minus 3i. Now the numerator, two completely different terms, so I've got to FOIL it. 6 times 4 is 24. 6 times negative 3i is negative 18i. Negative 3i times 4 is negative 12i. And then negative 3i times negative 3i is a positive 9i squared. Okay, and then my denominator, 4 and 4, is going to give me 16, minus 3i and 3i is going to give me 9i squared. Okay, so I've got 24. Negative 18i minus 12i is going to give me negative 30i. And then that 9i squared turns into
9 is 9.
And then I've got 16.
Plus 9.
That negative 9i squared turns into plus 9. And I clean up my numbers. 24 minus 9, 15 minus 30i in my numerator. And 16 plus 9, 25. Now, I'm going to look. 15, 30, and 25. Can I reduce those? Yes, they can all be divided by 5. So I'm going to simplify. So 3 minus 6i over 5. Y'all good with that? Any questions? All right. Now this next one, you've got to pay attention to what operation is in the middle of the two parentheses in your numerator. Okay, I don't just start multiplying those. I have a subtraction symbol. So I've got 7 plus I. I've got minus the entire thing. So that's going to turn into minus 6 plus 3i. And then I'm going to FOIL the denominator. So I've got 1 times 2, which is 2. 1 times 5i, which is 5i. Then I times 2, which is just 2i. And then I times 5i, which is 5i squared. Okay, so I'm going to clean up. 7 minus 6, 1. I plus 3i.
4i.
So 1 plus 4i is my numerator. And then
2 plus 7. Minus 5.
So 1 plus 4i, and then my bottom becomes
Negative 3i. 3 plus 7i.
negative 3 plus 7i. Now, that's my simplified form, but I still have an I. So this is where I'm going to multiply by negative 3 minus 7i. Okay, so I'm going to FOIL the numerator. 1 times negative 3 is negative 3. So, and then 4i times negative 3 is negative 12i. 4i and negative 7i is negative. Good. Okay, and then my bottom, negative 3 times negative 3 is 9 minus.
49i.
Very good. Alright, so I've got negative 3 minus,
19.
and then plus 28. And then my bottom is 9 plus 49. So negative 3 plus 28
25. Minus 9 is 9.
over 58. And I cannot divide those by the same number, so that would be my final answer. Y'all good with that?
How did you get the 7 plus 5 when it's 6 plus 3 from the original?
So this, I'm subtracting the two. I'm not multiplying them in the numerator. So that's like what we did right here. So when you got your minus, you drop the parentheses, but everything behind it, you're actually distributing that negative 1.
Oh, okay.
So that's how that turns into a negative 6 and a positive 3i. Okay. Do we have any other questions?
No.
Okay, so y'all are gonna have a quiz over that next class. So make sure that you get your work done and you practice, and let me know if you're struggling.